Hello, and thank you for joining us today for our webinar on the industry's latest trends presented by Contech. Before we get started, I'd like to take some time to cover a few housekeeping matters that will ensure we have a smooth presentation. We've placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH certificates for today's presentation. If you have any questions, please type your questions into the question box. We will be taking questions throughout the webinar. The webinar is scheduled to last for 1 hour. We will have about 50 minutes of presentation, followed by a question and answer period. When you logged onto the webinar, the GoToWebinar window will have appeared on your upper right-hand corner of your screen. This window will minimize by itself after a few moments so that it does not interfere with you viewing the webinar. If you would like to maximize this window, just click on the small red arrow and the window will be maximized. The blue box in the GoToWebinar window will allow you to minimize or maximize the presentation so you can view it in whatever size works best for you. Presenting today will be Scott Aston. Scott is the Vice President of Structures for Contech. Also presenting today will be Tim Kilty. Tim is the Director of Precast Bridge Development for Contech's Atlantic region. He has over 20 years of experience in the precast concrete industry. I'd like to turn over the presentation to Scott.
Thank you very much, Lisa. Good morning to everyone that's on the line. We believe we have lined up a great webinar for you here today. Just to set the stage a little bit, the primary goal of today's webinar is to educate everyone and inform you about some of the industry's latest bridge innovations. In about 10 minutes or so, Tim Kilty is going to be presenting to you on that topic. But before he does that, I just wanted to take a few moments and talk to you a little bit about who Contech is, a little bit about where we've been for the past 80 years as it relates to our bridge structures. But even before that, I want to set the stage a bit as to who we have on the line and who's presenting. So you have Lisa, Tim Kilty, and myself located in our headquarters office near Cincinnati, Ohio. On the line, we have hundreds, actually, approaching 1,000 engineers from all over the country. In addition to that, we have owners representing DOTs, cities, and counties, all of which will be attending today's webinar. As Lisa said, it's going to be very difficult for us to have any type of dialogue with the audience because of the number of folks that we have on the line, but we do encourage you to submit your questions online and through the chat box, and we'll try to address those as best we can throughout the presentation or at the end. So just a little bit about who Contech Engineered Solutions is. We are a site solutions provider. You can see on your screen a representative site plan that shows all sorts of site civil infrastructure that Contech can supply and provide and work with you and your client on. This includes, as you see along the bottom, bridge, drainage, erosion control, retaining walls, etc. And you can get a little bit of a sense of how those might be configured on an individual site plan. Most importantly, I want you to think of us as a site solutions infrastructure provider. But more important than that, and more important than just providing products or solutions, Contech aims to be your project partner. We believe that the technical support and the things that we do beyond just the products that we supply is really what makes us different from other companies that you may work with. We have a number of engineers and CAD specialists located in satellite offices all over the country. In addition, we have our sales engineers and project consultants that cover all 50 states, and they're ready and willing to assist you or your clients with any projects or needs you may have on any of the products that you see. But most importantly, as it relates to today's presentation, they're available to assist you with any of the bridge innovations that we'll be talking about here in just one moment. When we talk about being your project partner, just a little background, Contech really defines and separates a project into 3 major categories. We have the planning and solution development stage, we have design assistance, and then installation of support. You can see some of those things listed on the screen as to the ways in which Contech has worked with engineers like yourselves in the past to assist throughout the project. That might include a design your own bridge, assistance with foundation calculations. And Tim's going to highlight a couple of those things as we go through the presentation today, but it's very difficult for us to give a full representative sampling of the types of things that we've assisted with. I would just encourage you to reach out to your project consultant if you have any needs related to any of the items that you see here. Now that we know a little bit about who Contech is, I want to talk to you a bit about Contech's Bridge Solutions portfolio. You can see here listed quite a few of the very prominent industry brands related to pre-manufactured bridge systems. The Contech Structural Plate Solutions, Conspan and Bebo brands, and then the Truss portfolio of brands along the bottom, including Continental Bridge, Steadfast Express, and US Bridge. Those are the brand names and logos. If we look at those, how those may lay out on a map, we can see here at the top of the page, we have our multi-plate solutions. And then what we have along the bottom in the x-axis is giving us a little bit of an idea of how those spans might lay out in the span ranges for the particular product lines. So we have our plate portfolio of solutions, Precast bridge portfolio of solutions, and then Truss, including both Vehicular and Pedestrian. I'm going to take just a couple of moments to share with you a bit of background on each one, and then Tim Kilty is going to get into not any detail about the solutions you see here, but details about the new innovations and the industry advancements that we're making to further drive this product portfolio and further help you provide solutions for your clients. So the Contech Structural Plate Solutions we can see pictured here. There's a number of different shapes and sizes, but structural plate, if you're not familiar with it, is a corrugated metal plate product. It's manufactured and shipped out to the job site in sheets or stacks of plates on a truck. A contractor can then assemble those into various shapes on site to meet clearance diagram, hydraulic needs, etc. And then you get a sense here of what some of those finished looks may look like with the end treatments that are added, whether those be metal, block wall, etc. So beyond the product itself, one of the reasons that we see engineers like yourselves most commonly utilizing it on projects is partly because of speed, partly because of economy. Structural plate tends to be one of the most economical solutions to many bridge crossings. We also see a benefit in that many counties, agencies, DOTs are able to utilize their own crews to assemble the projects on site because very minimal heavy equipment is needed. But the last reason why we see folks using structural plate is the versatility of the sizes and shapes. And that's what this slide is really meant to depict here, all the different sizes and shapes that are available. From full round structures and underpass or pipe arch, all of these have an invert, meaning you don't need foundations. On the right side, we have an idea of some of what we might call our buried bridge structures that have foundations underneath and can clear span a stream, provide for that environmental or natural stream crossing underneath. We're not going to get into a ton of detail about these, but I just want to give you some sense as to the extreme versatility that we have with shapes and sizes that can help meet whether it be a hydraulic, clearance box requirement, any other particular types of needs that you and your client may have on a project. Next, I want to highlight our Precast bridge product line, which, as I mentioned before, includes both the Conspan and Bebo concrete arch systems. Those are fully modular, pre-manufactured systems that are delivered to the job site on trucks. They come complete with precast head walls, as you see here over top of the structure, and precast wing walls. All of those can be put together to make a complete bridge system. Tim's going to talk to you in a few moments about another addition to this bridge system, which is our precast foundations that we're very excited about. Adds yet another prefabricated element to the complete bridge system. As far as the different shapes and sizes for our precast bridge, the Conspan shape is a very distinctive one in that it has vertical sidewalls and an arch top. Then the Bebo systems have more of a high profile arch here, or a pure arch. We see Conspan as being a nice blend of being able to take the load, or have strong load carrying capacity and be able to take high loads, but also a larger hydraulic opening. We see the Bebo E and C series most often being utilized in heavy loading conditions because of the strength of the arch, or when you need large clearance box openings. And then the last part of our portfolio that we'd like to talk about is truss bridges. Just a quick overview, Contech works with engineers to provide both pedestrian and vehicular truss bridges. Here you see pedestrian on the left side of the screen and vehicular off to the right. The Continental product line is really a highly customized type of pedestrian bridge solution. The Steadfast Express is more of a standardized solution for pedestrian applications that's built around speed and being able to get you and your client what's needed very rapidly. And then US Bridge represents the vehicular portion of the product line. First, I want to talk about Steadfast Express for just a moment. You know, we know that time and speed of delivery and speed of execution is very important on just about any project. So what we've done here is tried to slim down the offerings to a standardized set of spans and widths, a standardized set of finishes, and then standardized set of guardrail, handrail applications, so I should say handrail, And because of that slimmed down number of selections, we're able to provide drawings in 3 days and manufacturing in 6 weeks to dramatically expedite your project. Now we know that standardized fit doesn't work on everything, so in addition to that we have the Continental product line, which offers a varying different types of styles and applications so that you can customize it to your particular project needs. And here you see some of those styles and some of the associated finishes where you and your client can balance the speed versus the cost versus the aesthetic look that they may be trying to achieve on a project. And then the last part of the portfolio that I'd like to talk about is the vehicular truss bridges. Again, it's under the brand name of the U.S. bridge, and here you can see the variety of different styles, again, trying to balance the aesthetic look versus the speed versus the economy that you might be looking for on your particular project. Like I had mentioned, Contech has an extensive history in providing all sorts of pre-manufactured bridges, from precast to plate to truss, going back 80 years and now approaching 80,000 installations. With comprehensive support and installations in every state, it would be impossible to try to give you a full understanding of the types of projects that we participated in. And really our goal today is not to tell you about the history, but to tell you about the future that Tim's going to talk to you about here in just a moment. But I did want to show just a couple of applications of the types of projects that we participated in. So here would be an example of a railroad going over a pedestrian crossing, an airport going over a roadway, a stream or environmental crossing, a pedestrian crossing. On the next slide we have slip lining and the ability to place units underneath of a road that's in service, a pedestrian underpass, a curved railway tunnel. Just about any application you can think of serving just about any market is something that we've participated in the past, and we look forward to participating in the future. So we're not going to spend any more time on that, but I did want to give you some sense of just the breadth of projects that we've participated in the past and how engineers like yourselves have seen the systems be very useful in solving some of their design challenges. So with that, I've told you a little bit about the markets that we serve and applications. Did also want to take a little bit of a step back and say, what is Contech seeing as it relates to how the market is trending? So as we look back over the past 3 years or so, we've really seen the market be extremely flat as it relates to both highway, residential, and commercial. It's been bumping along flat for the past couple of years. Unfortunately, this year, we are seeing just a little bit of a tick down in the highway and highway spending due to the budgets that the DOTs and the local counties and municipalities are seeing. But we are beginning to see just a little bit of a tick up, primarily in commercial, to a lesser extent in residential. And that's a bit of a national look as to what we're seeing, but I'd be really curious to kind of hear from all of you as to what you're seeing. So we're going to introduce the first of what we're calling poll questions throughout the webinar, just to gain a little bit of feedback. And so you will be voting and clicking some buttons on the screen, and I'll turn it over to Lisa to walk us through that.
Thanks, Scott. You should see a poll on your screen in a few seconds. Please take a moment to answer. We will collect the answers and then talk about them at the end. Okay, so the votes are coming in. Thank you very much. Please keep them coming. We'll keep the poll open for a few more seconds. Let everybody get a chance to vote. It's looking good. Okay, I'm going to go ahead and close the poll. And the results seem to be 39% are seeing highway, 26% are seeing commercial, 17% say other, 12% residential, and 6% oil, gas, and energy.
All right, thank you very much for that, Lisa. And I think, that parallels, as I said, we're seeing highway tick down a little bit, but it is still representing the largest portion of the projects that Contech is participating in. Maybe seeing things tick up a little bit there on the commercial side, which is a positive sign for all of us. So with that, hopefully that gives you a little bit of sense of where Contech's been over the past 80 years with our Bridge Solutions portfolio. I'd like to turn it over at this point to Tim Kilty, who's going to walk through where we're headed in our new generation of innovation.
Hey, thanks, Scott. Scott did a really nice job giving a comprehensive overview of really what is our extensive civil infrastructure portfolio. He talked a little bit about our substantial history, as well as the amount of bridge installations that we've done and the associated applications. Over almost 80,000 bridge installations, pretty substantial. So I don't want to talk about where we've been. I want to talk about where we are headed. We have 3 new innovations that will change the way you design and specify buried bridges. Innovation number 1, the Conspan O Series, or we also call it the Optimized Series. The Optimized Series is the most efficient 3-sided structure in the industry today. It features a 20% reduction in concrete over the original Conspan shape and almost a 40% reduction in concrete over your traditional 3-sided flat top. Innovation number 2, Bridge Core. Bridge Core offers the longest deep corrugation plate lay lengths in the industry, the longest deep corrugation plate lay lengths in the industry. I'll talk about that a little bit here in a second. Innovation number 3, Express Foundations. Finally, a hybrid foundation, if you will, that is precast and poured in place. And the Express Foundation, it's a perfect blend of the speed and efficiency of precast coupled with the economies of cast in place. So let's take these one at a time. Let's start with the Conspan O Series. Now, a little bit of housekeeping. Usually the question comes up when we do these seminars across the country as to what's going to happen to the original Conspan shape. Will it be in your portfolio? And the answer is yes. We are rebranding it as the B Series or the Basic Series, and we see a place for the original Basic Series for grade separations and that type of thing. But I think as the presentation, as we get through this webinar, it'll be pretty clear to you that as it relates to hydraulic crossings and clear spanning and wetland type applications, the O Series will be the system that you're going to want to be designing in the future. So the new system, O Series, is going to be the designation as we move forward. So let's talk a little bit about that. So why would we optimize? Conspan's been designed by, specified, and installed by more DOTs than any other 3-sided structure in the industry. So why would we change anything? Why would we optimize? Well, I think to answer that question, you really have to kind of go through the timeline and the history of innovation at Contech. So on your screen you see a timeline that starts at 1980. And really the innovation started before that as it relates to precast bridges. So if you go back to 1960, the original precast arch was developed. And in 1970, the 3-sided flat top evolved. And both of those were very good structures on their own. But in the 80s, the Conspan arch box shape was born. But Conspan and Contech engineers did not stop there. The innovation continued. In 1989, the first precast wing walls were developed. Really throughout the 1990s, the product grew to the point where the Army Corps of Engineers included Conspan by name in the HEC-RAS hydraulic modeling program. From 95 to 2005, spans grew from 36 feet to 60 feet. And throughout this entire period of innovation, the engineers at Contech continued to work on ways to find thinner sections and more efficient steel areas. Hence, the O Series. Now, the optimized shape, as the name would imply, it's been optimized to increase the span and waterway over the original Basic Series. So again, just a little bit of housekeeping here, just to clarify. The original bridge-in-a-day concept that we always talk about when we come to your offices, the total set-in-place precast structure complete with head walls and precast wing walls, that will remain the same. We will still have precast head walls and precast wing walls. But what we're going to focus on today is the arch itself. So if you look at this drawing, you'll notice that the basic arch top has been retained while gaining in span and waterway area. And we've done that by manipulating these legs. So this simple manipulation of these legs, this outward manipulation of this legs, what it does for us is it reduces the stress in the haunch, which significantly results in thinner concrete section and reduced steel areas. And it does that by mobilizing much more of this arch action than the original Conspan shape did. So here's an animation that really tells that story. You see that when we were going through this process, it was what was the optimal span to create? Was it 10 degrees, 20 degrees, 30 degrees? And what we ended up with was a 30-degree spread on those legs. So when you rotate these legs out, as I mentioned, it mobilizes more of this arch action, and the result is a thinner, is less stress on our haunch area, resulting in thinner sections and thinner steel areas. And looking at the moment diagram, I think it gives you a better picture of what we're talking about here. The red line represents the original Conspan shape or moment diagram, and the blue line represents a moment diagram associated with the O Series. And if you look at the original Conspan, although it did take advantage of the structural capacity of the arch and the hydraulic efficiency of the box, but if you look at this, it really is a pretty inefficient turn around that corner there. And so by rotating these legs outward, you can see that we have maximum positive and negative moments have been reduced associated with the O Series. kind of closing out that loop on the history of innovation and why has it taken us so long, if you will. If you think about the arch and the structural capacity in the 1960s and then the hydraulic efficiency of the flat top, those were blended in the early 80s to get the conspan arch box shape. And now we have the best blend of hydraulic efficiency and structural capacity in the O-series by mobilizing and rotating out these legs. Now, I think 2 or 3 slides ago, I used the term simple manipulation of these legs. It might have been simple, but it's taken us 32 years to get here. And we're pretty excited about the opportunities that this presents the industry and your clients. So let me go back here. What are the applications that you utilize the system on? Really, any application you've been involved in with 3-sided structures, box culvert, those type of crossings, any of those applications the O-Series will apply just more efficiently. So whether it's wetlands, clear spanning, hydraulic optimization, the O-Series will work very well. Now, I did talk in the very first slide about where is the B-Series going to fit in our portfolio, and we really think there's a place as it relates to grade separation. And when we have a grade separation project and we're working with you for designers like yourself, we'll look at bridge core, multi-plate, Bebo arch, O-Series, B-Series, whatever's the appropriate structure for your particular grade separation project. A couple quick design challenges just to give an example of the savings that we're starting to see associated with the O-Series. The one on the left is a clear span application. The one on the right is hydraulic. So let's take the clear span application first. So the requirement here is just a clear span, 25-foot span. The rise doesn't really matter. We're just crossing the wetlands, if you will. So waterway area is not a factor. We're just trying to get across this wetlands. So with the O-Series, we would use a 25-foot span. Now with the B-Series, we would use a 28-foot span. So you might be looking at your screen and saying, okay, well, why is he not just using a 25 versus a 25 so we can get a good comparison? This was actually done by design because this is a really good time to point out the fact that the O-Series offers 53 spans as opposed to the original B-Series shape, which came in 4-foot increments and only offered 12 spans. So if you had a 25-foot span, you had to jump to a 28-foot span. If you had a 17-foot span, you ended up jumping to a 20-foot span. And that's the way the industry has worked for about 25 years. So the O-Series now gives us the opportunity to zero in on the span that's necessary for your project. So if you do this comparison, you'll quickly see that, let's move on down to the concrete savings. The O-Series 25-foot span would represent 1.96 tons versus 2.84. 31% savings in concrete and almost a 50% savings in steel. More importantly, when you can make lighter structures, and those structures can be placed in a longer lay length. So in other words, these are 8-foot lay lengths versus a 28-foot span, which was a 6-foot lay length. It does a whole bunch of additional things for you. Reduces the amount of trucks, reduces the amount of joints, could potentially, given the lightweight nature of the structure, could reduce the size of the cranes on the job. So all of that can add up to some total cost savings on the job. Crossing over to a hydraulic application, again, quick run through this. You need 190 square feet under 13 feet of invert. So we look at a 27-foot O-Series versus a 28-foot B-Series. Both of them about the same waterway area, 194, 195, but then you look at the concrete savings. 22% savings over the original conspan shape of concrete and almost or 40% savings as it relates to steel. Again, those are just a couple of quick examples, but we've done a lot of these already since we launched this structure, and we're seeing really some significant savings on all the projects that we've been working on with our clients. As far as solution develop, how do you work with Contech? That has not changed. The best source or the best resource we have is our project consultant. So I encourage you to sit down with a project consultant. He'll go through our project detail worksheet, which helps us organize the challenge that you have on your job so that we can provide the appropriate solution. We do have one more tool associated with the O-Series, and it's our series selection chart. So let me walk you through that series selection chart. It's a chart that has two sides. Has the selection chart on one side and a waterway area on the other side. The selection chart itself, it can look a little bit busy here, but it can be summarized pretty simple when you consider that the green shaded area down here represents your most optimized wetland crossings, and the blue shaded area up here represents your most optimized hydraulic crossings. So let's go through an example of how you would use this. You're in a preliminary situation. You know that you need about 200 square feet of waterway area, and you need to keep it under a headwater elevation of about 10 feet. So you come in from the left of the chart at 10 feet, you come over to where you intersect 200 square feet, come down to your x-axis, and you end up with a 27-foot span. Now, one thing to point out when you get a hold of this document is that we spent a lot of time and effort into these bold black lines identifying the most optimized series that you want to start off with when you're doing your evaluation. So when you come across and you intersect your waterway area here, whichever black line that intersection is closest to is going to be your most optimized solution as far as the series, and that'll make some sense on the next slide. But the reason that that's important is because, remember, our old B series only had 12 spans. Now we have 53 spans. So we have a 27-foot span in the 200 series, but we also have a 27-foot span in the 300 series. And using this chart properly will zero you in on the most efficient series that you should be working with. So you flip the sheet over, you can see that you got a 27-foot span, 9-foot 4-inch rise, 194 square feet, so we're close to that 200 square foot waterway area that we were looking at. That's just a kind of a quick run through on that. Closing out the thought on O series, again, all the tools that we've had historically are available for your use, including our photo manipulation tool, which allows you, if you have public hearings where you need to present what these structures are going to look like, or if you're working with a client who maybe wants to look at something beyond the CAD drawings, our marketing folks can go ahead and simply put in a picture in your particular stream crossing, if we have a picture of that stream crossing or the existing bridge, of what that product will ultimately look like. Innovation number 2, BridgeCore. BridgeCore really builds on Contech's long history of designing and manufacturing corrugated and aluminum steel structures. The essence of BridgeCore is in the deep corrugation pattern. We're working, if anybody's familiar with the original multi-plate, it was a 6x2 corrugation pattern. The BridgeCore is a much more robust 15 by 5.5 deep corrugation pattern. It nearly doubles the stiffness of the structure, resulting in longer spans, higher fills, high live load capacities, all along reducing the material thickness of the product. So what are the applications? Again, like we talked about with Conspan, all the same applications you've used in the past, just more efficiently. Whether it's wetlands, mining, railroad, conventional bridges, whatever it is, just a much more efficient structure to attack those with. From an available shape standpoint, we have round up to 50 feet in diameter, single radius arch from 22 to 54, multiple radius arch, 22 up to some custom-made 65-foot spans, and then box culvert 18 feet up to 45-foot span. Quick design comparison, similar to what we did with the O series. This was a project we looked at recently, and we utilized our super span and our BridgeCore to see which one would be most efficient for the client. It was a wildlife crossing. It needed a 40-foot clear span opening. So the super span was a 42-foot span, 3-inch, versus 42-foot 7 for the BridgeCore. So let me draw a couple things that are important. The minimum cover on the super span was 48 inches in this particular application, as opposed to, because of the stiffness associated with the BridgeCore, able to handle only 30 inches of cover. And then the big difference is your gauge. We go from a 1 gauge to a 7 gauge, which represents a huge saving in material. You're looking at 244,000 pounds versus 176,000 pounds. It does a bunch of things for you. Certainly cost is part of it, and then it reduces the amount of trucks necessary to ship those jobs. And if anybody's familiar with transportation costs and gas costs and everything over the years, you can eliminate a couple trucks. That can make a big difference on your project. So in this case, the BridgeCore represented a 35% cost savings for the entire installed structure. We'll work with you on your particular project and figure out what can be the potential savings and which is the right product for your particular job. Closing out the thought on BridgeCore, again, just like we talked about with O-Series, our project consultants really like to get involved early. We'd like to run a finite element analysis so we can optimize the structure gauge of your particular project, and that takes about 2 weeks. So again, the earlier we can get involved, the more efficient of a structure we can provide. And then from an installation standpoint, we have certified BridgeCore assemblers that are available. We can recommend these to the contractor of record, or if the contractor wants to be an assembler himself, we can go through the process of how we can certify that particular contractor to be a BridgeCore assembler. Innovation number 3, express foundations. When you think about precast foundations, I would offer the question, why have contractors typically used precast foundations? Well, in many cases it's been either speed, dewatering issues, maybe you got some real tight working conditions. It's never really been about cost. Well, today I'm going to walk you through a new system that can provide you some real cost savings. But let me come back to that here in just a second. This is sort of the evolution of foundations, if you will, as it relates to three-sided structures. The cast-in-place foundation is probably what we see the most on projects throughout the country. And your typical cast-in-place foundation, you've got some forming associated with it. You've got to place and you've got to tie your steel. You're certainly subject to some weather conditions, some washouts, that type of thing. But that's typically what we see as a cast-in-place foundation. Now, the evolution of the precast foundations, if you think about a precast foundation, it's nothing more than a manufactured version of the cast-in-place design. Okay, so whatever your cast-in-place design is, we're going to manufacture that at a plant, break it up into sections that are suitable for transportation, and then ship it out to the job. So never really done as a cost-saving item, really for speed, dewatering, tight conditions, those things we talked about before. And the original precast foundations were just kind of blocks of concrete sitting next to each other. In fact, if you go way back to some of the early precast foundation, there wasn't even a connector between the joints. So the second generation kind of had some shear connectors, if you will, some connector plates between those joints, which started to give you some sort of continuity. What we like at Contech and what we've been working on for 10 years is we want a system that gives you the continuity associated with a cast-in-place foundation. Well, this third generation of precast foundations started to get you there. You had blocks of concrete, then you'd have maybe a 3-foot void in between those blocks. You'd have overlapping steel, and then the contractor would do a closure pour. So really this was the first type of system that gave some level of continuity between those foundations until now. What we have now is the Precast Express Foundation. Well, I keep using this tagline, is that it presents the efficiencies and speed of precast coupled with the economies of cast-in-place. What's the economy of cast-in-place? I think we got to walk through that a little bit. If you think about a cast-in-place foundation, you've got to form, tie, set your steel. Okay, that's a little bit cumbersome. That's kind of the complicated part. The easy part of a cast-in-place foundation is just dumping your poured-in-place concrete. That's where the economies come into play. So what if you could build this concrete shell, this precast concrete shell, complete with these sidewalls, complete with these cross members, at the manufacturing plant, and be able to ship it out to the job site, and then take advantage of the cast-in-place, the economies of cast-in-place, which is that poured-in-place concrete, and do that out on the site. And here's exactly what we've done. This is kind of a view from the underside, because when these units come out there, this shell comes out there, 6-inch walls, 12-inch cross members, and these structures are complete with shop-applied, transverse, and longitudinal steel. So all your steel is in that foundation. So we've taken advantage of all those efficiencies at the plant, and now all the contractor has to do is go ahead and take advantage of the most economical piece of cast-in-place and pour that concrete into the shell. It's really a neat, efficient system, kind of giving you a sense of the success or the opportunity here. If you think about what I just showed you, that concrete shell, here's a typical example of a 6x2 foundation. So if we're to build a 6x2 foundation utilizing express foundation, that shell is only representative of 27% of that entire precast foundation. The additional part of that foundation is that poured-in-place concrete, that 73%, which is your most economical piece of a foundation. Closing out the thought on express foundation, the wing wall foundations, they were typically about a 2x2 foundation. We don't need that. We've designed a trapezoidal precast foundation, which saves us about 20% on material on those wing wall foundations versus a rectangular foundation. Construction process, contractor can go ahead and excavate, prepare the foundations. He can unload and set those precast channels into the hole there. And then I mentioned earlier that all your longitudinal and transverse bars are shop applied. When you have a joint, if the structure is long enough that you're going to have multiple of these express foundations, when you have a joint, we'll provide lap bars, and the contractor will, that's all he's got to do is go ahead and tie those lap bars where you have joints. We just did a job, Scott's going to talk about it here in a little bit, and each one of the precast foundations was 27 feet long for a structure that ended up about 150 feet long. And so we did have a series of joints associated with that. Following the tying of the lap steel, then you're going to go ahead and set your bridge units. Now this is an important point too, because I haven't mentioned anything about pouring the concrete into that foundation. In most situations, you're going to be able to set the bridge before we go ahead and pour the concrete into this shell. And that does a couple things for us. It certainly makes for a much more efficient precast set. Get your foundations done, you get your units done, head walls, get your joint wraps on. But it also takes away a step that used to be associated with three-sided structures where you had to grout the foundations into the unit. So that's no longer necessary because that will take place when you go ahead and pour that concrete into the foundation, tying the entire structure together. Last thought on express foundations is from a support standpoint. Many of you worked with us in the past know that we'll do as little or as much as you would like us to do, whether it be just providing horizontal and vertical reactions, or if you've got some bigger fish to fry and you've got some geotechnical information and you'd like us to do some design calcs and some foundation sizing, again, we'll be happy to do that as well, as little or as much as you would like to do for your particular project. So now I would suggest that now that everybody gets a sense of what these new three innovations are, O-Series, Bridge Core, and Express, I think Lisa has another poll question so we can get a sense of where people would be headed and which one of these systems they think they might have a chance to take an opportunity of.
Thanks, Tim. Okay, we are going to go ahead and launch the poll. As Tim stated, which innovation are you most likely to utilize in an upcoming design, the O-Series, the Bridge Core, or Express foundations? As a reminder, as we're waiting for all the participants to take the poll, please log your questions onto the question bar at the right. We will be working to try to answer these at the end following the webinar session. If we don't get to your question, we will be sending out an email of FAQs, and someone will follow up with you. Okay, we have a lot of good votes coming in. I will leave it open for a few more seconds. Please get your votes in now. All right, we're going to go ahead and close the poll, share the results. Tim, as you can see, the O-Series actually has a 56% response rate, followed by Express Foundations at 27%, and then Bridge Core at 16%.
Fantastic.
All right, thank you very much, Lisa. I mean, I think what we're seeing here is hopefully that you all on the line are seeing some of the same value in these innovations that we're seeing at Contech. Certainly your peers across the country are, and just wanted to give you guys now a couple examples of how engineers have been utilizing these new innovations in the relatively short time since the products have been launched. You know, we've just introduced these to the market in the last 4 or 5 months, and frankly, the response has been overwhelming to all of the innovations. I want to go through one project highlighting each one. The first one we'll talk about is O-Series. You can see here it's for a project called the Duanesburg Churches Road Bridge in Duanesburg, New York. What you see here are the trailers lined up in order to prepare for the installation of this particular O-Series bridge. And what they had done is staged the trailers overnight such that first thing in the morning when the contractor was ready to install, all the units were lined up there and ready. So immediately upon mobilizing in the morning, you can see here the first arch unit being set into place. And one thing I do want to highlight is, if we advance to the next slide, you can see that that foundation that's underneath of these arch units is actually a 6-foot deep pedestal wall. And you might say, well, why do we have a 6-foot deep pedestal wall and you cover it all in? This is actually becoming common practice in many areas where they'll put in a deep foundation, go ahead and backfill and add riprap around that foundation as a scour countermeasure prior to coming in and putting any of the arch units in, because the construction process is greatly simplified. And then we can set the arch units right on top as you see here. So the arch units have been lined up on the foundation, and then here you can see a finished photograph where all the head walls and wing walls have been installed. I also do want to highlight, you know, Tim was talking about a bridge in a day, and that's part of what we pride ourselves on here with these precast systems. This piece of wing wall / head wall that we see over top of the slope portion of the leg is a new element for us because the legs are at an angle. You know, that item along with the other walls, you know, went in very quickly and rapidly. This entire structure was installed somewhere in the neighborhood of about 3/4 of a day, so certainly meeting all of our bridge in a day standards that we've set with the Conspan B series over time. Next project I'd like to highlight, It's actually our bridge core product line. This was for a project at Pierre Creek, called Pierre Creek in Boyd's, Washington. And you can see here the assemblers putting the structure together. If you've never seen structural plate, this will give you a pretty good feel for how things go. And one of the things that I want to emphasize here, a key innovation that Tim hit on as part of our bridge core product line is the fact that each sheet has 3 corrugations. Because we have 3 corrugations, obviously that makes the sheets longer than maybe other types of offerings that are available. And because of that, you need fewer overall sheets. So it allows for the installation to go much more rapidly, ultimately resulting in cost savings for you and your client. Here you can see then an excavator lifting into place those sheets. One of the other things I want to highlight as part of our innovation not only is the product, the lay length of the sheets, but also the fact that the manufacturing process that we're utilizing to manufacture these is state-of-the-art, and the fit-up of the plates is exceptional. So as an assembler is trying to put them together on the job site, one of the key things that can slow a project down is if you get inappropriate or incorrect plate fit-up. The projects that have been installed, the plate fit-up has been very good, and you can see here how those are going into place. And then lastly, a finished photo showing this environmental crossing, obviously preserving the natural stream bottom and provide everything that the owner was looking for on this particular project, which was a great blend of clear spanning and economy of solution. Last project I'll highlight is with Express Foundations, and it's the Frenchtown Brook Road Bridge replacement in East Greenwich, Rhode Island. This was with the Rhode Island DOT. Here you can see the units being set in place, and you can see all that steel laid in there just as Tim was talking about a couple of slides earlier. Once the units have been installed on this particular project, all of the units are laid out in this long row. The contractor went ahead and backfilled around the foundation. It was easier to do it at this point rather than after the arches were installed. And then on each of the cross members here, you can see shim packs where the arch unit legs will sit down on top of those shims. 2 arch units will come down on each cross member. The next slide, as Tim mentioned, is showing the placement of that reinforcing steel. Again, want to emphasize all the reinforcing steel is placed inside, but the steel that needs to be placed on site is just across the joint. So you can see that joint here along the left side between the foundation units. Contractor tying the lap bar splices to create that continuity over the entire length. And then this is the other piece of steel that needs to be attached. We believe it's very important to have continuity between your arch unit foundation that you see here and your wing wall foundation that you see at the top of the screen. So again, these contractors are threading through the holes these bars into couplers that are embedded inside of the wing wall foundation. Those bars then stick through the holes and come into this void area, such that once this is all filled up with concrete, we have excellent continuity between the arch unit foundation and the wing wall foundation, which we believe is critical to the long-term performance of any structure. Now we have the arch units being set into place on top of those foundations. Again, the concrete has not been placed inside of the foundations yet. They're all open cell at this point. And then the last photo shows the contractor then has placed the foundation, poured in place concrete in there. And because they were able to do that after they set the arch units, it does eliminate the grouting step, further speeding up construction, further adding savings and value to that client. I can tell you that the DOT was just extremely excited with how this project went. Really embodied everything that they were after for accelerated bridge construction. The project was completed 4 to 5 weeks earlier than they were expecting, and the contractor was able to obtain a very significant early completion bonus. So coming away from this, not only was engineer like yourself very excited, the owner and the contractor, all in all an excellent representation of what we're trying to achieve with Express Foundations. So with that, we're going to transition the presentation. We're very aware of the time. It's 45 minutes after the hour, and we will be finished on time. I know that at certain points in these webinars, this tends to be the part where it may be difficult to get focus. We're going to go through just 3 more industry trends that we feel are very important to what's happening out there and how engineers like yourselves are designing structures. But before we get into it, just want to kind of survey all of you to understand, what you think is driving your bridge type selection and design. So which of these items below here do you think are influencing that? So Lisa, do you want to jump into the poll?
Thank you, Scott. Okay. As Scott stated, which of the following items are in consideration for your design other than cost? This is a multiple choice answer, so please choose all that apply. We do have a good number of results coming in. I'm going to leave the poll open for a few more seconds. Please don't forget, this is multiple choice, so you can select more than one. All right, I'm going to go ahead and close the poll. As we are seeing about 61% say environmental and permitting, 54% is accelerated bridge construction, 53% clear spanning, followed by 30% buried bridge versus culvert, and 22% buried bridge versus conventional bridge.
All right, that's great. Lisa, I appreciate that information. Part of why we're asking this question before going through the information is it confirms a little bit of what we believe, and that is, maybe some of our nomenclature or some of what we talk about related to buried bridge structures may not be vernacular or terminology that all of you are used to seeing and hearing about, but certainly accelerated bridge construction and environmental are. So what we'd like to do is just take a couple moments to introduce how Contech classifies different types of bridges. So what we have here is a map that basically shows all sorts of solutions ranging from precast box beams, steel plate girders, all the way to simple culvert solutions, whether that be four-sided concrete boxes or some other culverts. We more or less believe that these fit into three major categories, that being conventional bridges, buried bridges, and then culverts. I think many of you are familiar with what we might term a conventional bridge or a culvert, but might be less familiar with the buried bridges. That's a large part about what today's session is about, and that is trying to describe this whole idea of a buried bridge being something that has foundations on either side and can clear span a stream, but also has soil around it, which gives it some of the benefits of a culvert solution. And you can see many of the items we've talked about here today fit inside of these categories. And we have the associated spans where these fit along the bottom. We're finding that any time an engineer can take a solution that's higher on this chart and substitute for it something that's a little bit lower, such as our precast bridges or plate bridge, there could be a very significant savings for you and your client. So we'd like to just highlight a little bit of that concept. And what we'll highlight is the idea of utilizing a buried bridge in lieu of a conventional bridge. Here you see a conventional bridge that might span from bank to bank with abutments and piers and approach slabs. A different way to think about spanning over top of a roadway or over top of a stream would be, what area of mass do we need to carve out of that opening such that it would be effective for the project? And that's where we have this idea of a buried bridge structure. If you have a certain amount of hydraulics or a clearance diagram that can be accommodated by this much larger opening, you can use that opening instead of the conventional bridge, put some small head walls and wing walls on it, and backfill, and we think that results in some significant savings. Part of that savings is coming from all the bullet points that you see here. A shorter construction time, minimal long-term maintenance, because you don't have the bridge deck, you don't have the salting. Something that maybe folks think of less commonly is the fact that because we have soil around the structures, you're actually able to route utilities through a corridor over top of the structure, which can be some pretty big savings. Those utility crossings can be somewhat cumbersome on the conventional bridges. And obviously the long-term or total cost of ownership certainly adds up with the maintenance on a conventional bridge deck. We've added this one photograph here. It comes from the state of Washington. Obviously it's a very large bridge, but it says bridge deck rehabilitation and approach slab replacement, $645,000. I think the intent of the sign here is actually to advertise that they're providing jobs, but certainly those maintenance costs do add up and can be minimized with a buried structure. This is a real-world example of where a contractor utilized a buried bridge structure in lieu of a conventional bridge for some significant savings. The bridge in the upper left here needed to be replaced, and the contractor was able to take a step back and say, well, all I'm trying to do is accommodate a clearance diagram for this roadway below. And so what they did was they put the BEBO twin leaf structure in here while the roadway up above was in service, added some head walls and wing walls and backfilled, and you can see here what resulted in some very significant savings in traffic disruption time, construction cost, as well as the significant, or construction time rather, as well as the initial cost, and then certainly you have all the long-term maintenance benefits that come into play. It's just one example of how engineers, contractors, and owners are working together to try to reduce the cost of projects. And the last item I'll hit in this category is buried bridges versus culverts. We know some of the limitations of culverts can be the fact that the opening size is smaller. We get some pier blockage and debris buildup, and the fact that the natural bottom isn't preserved. There are some benefits from a cost perspective at times, but I think if we look at the total cost of the maintenance and everything else that factors into utilizing a culvert, we can find that utilizing a buried bridge may actually offer some long-term cost savings and reduced maintenance, as well as all the benefits that you get on the environmental side. So what we have here are a list of bullets of why engineers like yourselves, we see them trending toward utilizing more buried bridge structures as opposed to culverts for certain crossing applications. So with that, we have 2 more topics that we're going to go through here. Again, we are sensitive to the time, and we know there's 10 minutes remaining. Tim just has 2 more things that he'd like to share with you about some of the trends in the industry towards how engineers are dealing with environmental challenges, as well as some of the accelerated bridge trends in the industry. Tim?
Thanks, Scott. I've got about 6 more slides to go through here, and judging from the poll, it's obvious that clear spanning and environmental permitting is certainly an issue. So we find many of the projects that we're involved in are, hang on a second, a little technical difficulty there. Okay, many of the projects we're involved in are really driven by the span versus the hydraulics. And so, here's an example that, the goal is to minimize the impact of the main channel. The main channel in this case is the ordinary high water mark. And the definition typically is the area where you have this vegetative cover change. So this would be your high water mark. And so that's what we're trying to span. And the goal is to span that in many cases with either 0 or limited impact. And in some cases, what we're seeing a lot of designers do is work towards temporary impact. The result of these type of projects is that the structure selection is really driven by a number of things. You've got your span, you've got your stream geometry, geotechnical conditions, scour consideration. All those things have to weigh in to what the final structure selection is going to be, and that has to be economical as well to the project. So we have a number of solutions for this, and let me just take you through a real-world example where a temporary impact or a temporary measure was taken. So this is an example of a project that was done in Virginia. And the goal was that the engineer needed to provide a single-span crossing with a design discharge of 2,500 CFS. Additionally, the structure was supposed to have a natural bottom channel. Okay. The problem was that there was some significant discharge velocity that was resulting in some severe scour results. And so the engineer had to apply for a temporary impact permit, applied to the Army Corps, and received a temporary impact permit from the Corps of Engineers. So the result was that they were able to impact this. Now you're looking at this and saying, holy mackerel, that doesn't look like a temporary impact. But essentially what they did here is they were allowed to armor against the scour using an open cell Contech armor flex. Now essentially the existing stream material was excavated, removed, then your foundation was built, and then the full width of the channel was armored against the scour using the armor flex. Then the stream was rebuilt back over top of the armoring, providing a natural stream. This is actually the same project. You saw the picture when I clicked on it first. This is the end result. Using that temporary armoring, they ended up with what they were looking for, which was a nice, aesthetically pleasing natural stream when all was said and done. So we see a lot of engineers moving in this direction with temporary impacts. And then to close out the loop on the environmentals, as we demonstrated going through the O-Series, the O-Series really maximizes the span where it's needed most, and that's at the stream bed. Because of the rotation of these legs, it really gives us some real opportunities with some much more efficient structures for clear spanning type opportunities. The last thing I'll talk about is the bridge program. Scott discussed this when he demonstrated or presented the Frenchtown Brook Road Express Foundation project. And really, we've always tried to be in concert with what the Federal Highway has going on. The goals of the Accelerated Bridge Program is to use innovative means and methods to address the nation's infrastructure needs. And our goal is to make sure that we can have structures that are built off-site, that can reduce on-site construction time, minimize mobility impacts, minimize traffic disruption. We want to make sure that everything we do are in alignment with the prefabricated bridge elements and system goals of the Federal Highway Administration. And recently, there was a nice validation that came out to our efforts, if you will. In March of 2009, the Federal Highway Administration produced or published a document called connection details for prefabricated bridge elements and systems. Now, this is a pretty comprehensive document. It describes a variety of precast systems and different connection methods. But it really, as I mentioned, it validated our work with Federal Highway Administration, as our Conspan and our Bebo products are prevalent throughout this entire document with multiple illustrations, multiple pictures of our connection details and the utilization of these precast elements. In fact, the one here on the top right, if many of you have used our Design Your Own Bridge program, you'll see that that's usually the output you get from our website. If you've gone ahead and put a few parameters in, you'll get this little 3D isometric drawing. It looks something like this as to what the electronic version is of the project you're beginning to design. And that's exactly where the Federal Highway Administration took some of these illustrations for this document. So it's great validation that we're definitely on the right track and moving in the right direction with Federal Highway. And I know that we all like formulas, so I thought I would end our discussion with on accelerated bridge with the formula here. And the formula is pretty simple, that our Bebo arch system, our Conspan O-Series system, our bridge core system, our Contech structural plate system, any of those systems, plus the express foundation, which can be used with any of those systems, equals ABC, accelerated bridge construction. And with that, Lisa, do we have a chance to do one more poll where we could do that previous poll, and now that people have a sense of what our version of buried structure versus bridge or grade and some of those industry trends are, if we could see what some of the answers might be if we ran that poll again?
Yeah, let's launch that again, Tim. Hold on one second. Here we go.
Okay.
And the poll should be up on your screen shortly. Again, this is multiple choice, so please feel free to apply, select as many that apply to you. All right, a good amount of votes are coming in. We know it is almost the end of the presentation. Please go ahead and log your votes, and we should be finished here shortly. I'll just give it a few more seconds and wait for everyone to respond. All right, Tim, I'm going to close the poll and turn it back to you.
What are the results, Lisa?
Here we go. Changed a little bit. We are still at 66% for environmental and permitting. Clear spanning has gone up to 63%. The accelerated bridge construction, 56%. Berry Bridge versus Culvert is 41%, and Berry Bridge versus conventional is at 35%.
Very good. And thank you very much for going through that, and all of you for entertaining those results a second time there. You know, what we're trying to show here is that we do see these things as being strong trends, and we're just trying to help educate you on what other engineers out in the marketplace are doing so that it may help you to add value to your client. We are going to wrap up now, and in summary, I ask you to hang on just one more second so we can give you the proper instructions on the survey and how to achieve your PDH credits. But in summary, you know, we hope that you've taken something away from these innovations today that will help you to add value on a future project. We also help you take away that Contech really desires to be your project partner. As Tim said, we can assist with as much or as little of the design support throughout a project as you would like. There were some feedback and questions and comments coming in saying, wow, you guys are moving fast. This is a lot. There's a lot to catch up with here. Are you going to send out the materials? We're not going to send out the slides as you see them here, but I would say 99% of the material that we covered can be found on the landing pages or the new product pages on our website. So what you're seeing here is the landing page for those new products on the Contech website. We would encourage you to go out to that location, find whatever information you can. There's some great design tools out there for you as well. And certainly any other questions that you have, you know, we will be collecting information in the survey. You know, let us know if you'd like us to come see you. Let us know if you want a project consultant to meet with you. All those sorts of things. There are many ways to get in touch with us. So with that, you know, one question that did come up, you know, bridge core, how do we really summarize what the benefits of bridge core are? I think that one way to describe it is because of the deeper corrugation of bridge core, what we're seeing is that it can allow the material to be thinner as compared to some of our traditional multi-plate systems. It can also allow us to go to much larger spans. So if you just want to take those two simple nuggets away, thinner, which provides a material economy, or longer spans than the traditional solutions. But we know we are out of time here, and it would be impossible for us to address all the questions. What's going to happen at the conclusion of this presentation is that when you log out and when we stop, you will have something that pops up on your screen and asks you to complete a survey. We'd like you to complete that survey for two reasons. The first is, we need to have confirmation that you were on and attended and stayed through the full duration in order for us to be able to give you your PDH certificate. So the ticket to getting your PDH certificates will be completing the survey at the end of this. The other reason that we think it's very important to complete that survey, we are still trying to learn. We are trying to improve. We're trying to find ways to deliver information and content like we did today that's meaningful to you, that will be valuable to you. And so anything that you can help share with us at the conclusion so that we can make these things better is something that we take very seriously, and we will read through all the comments. So last thing I want to say is thank you all very much for taking an hour of your time to spend with us. We really did appreciate it, and we hope you got as much out of it as we did. Thank you very much.